I'll be completely honest, I did not know that Claude would go out and do this, and allegedly 30% of them contain potential indicators of AI poisoning. It turns out this was actually the Oregon State University open source lab. Hello everybody and welcome to the channel. I'm so excited for today's episode. In previous episodes, I gathered a large dataset of AI generated code, and my hypothesis is that production-based code models have already been poisoned. Now, this is an area which YouTube is not talking about, nobody else is talking about, so if you're interested in this kind of experimental research, please consider subscribing. I'm going to use a range of AI-generated techniques today to parse through the dataset I have and try and conclusively answer if GitHub Copilot and other models have been poisoned. So in my last video, I gathered a large dataset of coding-related prompts, put these into the DeepSeek Coder v2 Lite model via the Hugging Face Inference API, and I was able to get a dataset of coding-related prompts, as we can see here. So this is an absolutely huge dataset. We could use a variety of techniques to try and look for malicious strings, such as Yara rules. However, I've tried this already, and I believe using LLMs might be an alternative solution to quickly pass through this data and look for any malicious signs. So what we're going to do is we're going to use this prompt, which I created here, and we're going to upload this CSV into Claude. Now I have the premium version of Claude, so I pay a monthly subscription, and let's just see what happens. Full disclosure, I expect this to get immediately blocked due to the size of the CSV file, but let's see how large the context window is. So we're putting in our prompt. You are an AI cybersecurity expert, so we're trying to get it to adopt a persona, which is a very effective way to do some prompt engineering. You've been given a CSV of AI-generated code. We're telling it the column it needs to examine, and then look for signs of AI poisoning. I've deliberately left this very vague so it can use its chain of thought mechanism to try and come up with solutions which we may have overlooked. So let's attach our CSV and see if we get blocked. Let's open this up and wait for it to load in, and then we'll send it off. Let's see what happens. Okay, so it's actually writing us some Python code to parse through the data. That is a genius way of working with it. Let me just see what it's used. This actually looks like JavaScript, my bad. So it's writing JavaScript to parse through this data. Now it has an overview of the data, and it's looking for any signs. It looks like it's creating regex rules. So regex is a great way to search for strings in code, and Yara rules are a cybersecurity mechanism which basically just uses pre-built regexes to search for strings quickly. So it's still writing us the code. I'll be completely honest, I did not know that Claude would go out and do this. It's created an error, so it's fixing the error on the fly. And this is really the power of the latest Claude 3.7 Sonnet model. So it's checking for dangerous imports. This is intriguing. I had no idea that this would actually happen. Checking for cross-site scripting, shell commands, and now it's finishing up the code. So this is a very long function. It's worth noting that AI-generated code often uses quite long strings, and it uses very roundabout methods. Okay, so it's come up with an error again. If this continues happening, we may have to reset the prompt, try again, and be more specific in what we're looking for, because it keeps encountering errors as it tries to parse the CSV. Okay, so we can see Claude is actually writing this out in real time, and it says it's analyzed 734 code samples, and allegedly 30% of them contain potential indicators of AI poisoning. Now this is a really, really high percentage, and this immediately makes me suspicious as to whether this is a hallucination. So it's actually given us a nice list of entries that we can explore further. So first of all, we have entry 159, which is Wavebeat model hosting. Interesting. And this actually reaches out to an FTP endpoint. So I'm absolutely fascinated that Claude has actually picked up on a few suspicious looking things. So we're now going to ask it to re-output the highest risk identified entries and then print them out and do further analysis. So let me do some prompting on the fly. We'll say, great, please write out all high risk entries and perform your own analysis. And let's see what it comes back with. Okay, so as we can see, Claude is struggling again with the code, but I think we have everything we need in the pop-up on the right. I'm now going to go away for about half an hour, spend some time digging into the codes, looking for any indicators of compromise, and I'll come back soon and update you on anything that I find. I completed my analysis, and spoiler, all of them were false positives, unfortunately. So I went away and tried to create a revised prompt which will flag fewer false positives. Let's go back over to my Notion page. And if anybody's interested in Notion, I will have a link in the description. It's such a clean note-taking app, and you can get a 30-day free trial with no credit card required. This is the new prompt that I've come up with. You made several false positive errors. Think about this. Try to find 5 responses with true AI poisoning indicators of compromise. And then I've told it for each one to think about what it's outputting. So let's enter this prompt. And while Claude is thinking about this, we will go over the actual false positive mistakes it made. So the first one it flagged as malicious was this code for hosting a Wavebeat model on Replicate. Now, I don't know too much about Wavebeat, but it correctly identified an endpoint to a file transfer protocol file share. And it turns out this was actually the Oregon State University open source lab. It also used this eval statement, which is sometimes used in Python for remote code execution. However, it was being used in the context of model.eval, which is not malicious. The next one it looked at was a script for downloading images from an API. And again, the API was completely benign, and none of the things it identified were actually malicious. The third one it flagged up was looking at a script that used both OpenAI and Whisper APIs. And this was used to create a Node.js server application that integrated AI services. This got flagged up solely for the purpose of the API endpoints, and obviously neither of these are malicious. And the final one was a command to download Git on several operating systems. This looked suspicious because it used sudo, which is a command in Linux to use elevated privileges that is often used in malicious scripts. And obviously, this was downloading Git, so it was all good. So pretty much, the way that the AI failed was it was looking for strings, and it wasn't looking at the context around the rest of the code. So the response that Claude has come back with in this case looks far more interesting, and it's completely grasped what I wanted it to find, which is basically look for unusual responses to simple requests. So it's identified code about a cookie which is performing unnecessary operations. It's found an evaluation-based math function, an API endpoint code injection. Now these are all far more interesting, and they can't be classified as low-hanging fruit. This is going to require some actual manual investigation on my end, so I'll spend another half an hour looking at these and then come back with the results again. I completed my analysis, and in summary, none of these samples, unfortunately, have been poisoned. Each of these involved the model producing a chain of thought-like response where it came up with an alternative solution to the prompt. But in this case, Claude saw this and thought that the model had been poisoned to produce an unexpected response. For example, this JavaScript cookie manipulation is simply a better solution to the problem about local storage. So we really haven't been able to find any concrete examples of poisoning in the work done so far. Does this mean that production grade code models haven't been poisoned? I think not. I think I need to collaborate with more people. And if you have any thoughts on this, please leave some comments and get in touch. I'm really interested to see people's opinions, and I don't think enough research has been done in this space. So while we weren't able to find any signs of poisoning using LLMs, the next step is to use regex and Yara to parse through this big data set and look for any suspicious looking strings. Then, based on the strings that flag, pass this into an LLM or use the human eye to look for any signs of compromise. If you enjoyed this video, please feel free to share it, leave a like and subscribe, and I look forward to seeing you in the next one.